Sometimes you'll hear this operation called oil and chips, or tar and gravel. Maybe you'll hear bituminous seal coat, or surface treatment. But whatever it's called in your neck of the woods, most people who do the work simply say chip seal. And that's what we'll call it in this video program on chip seal application. We're talking about a road surfacing operation that consists of one or more applications of liquid asphalt and aggregate. Its purpose is to give the pavement a waterproof and skid-resistant surface. This presentation was developed for the Local Technical Assistance Program, LTAP. It's in 3 parts, so that after a few minutes of viewing, you can discuss what you've just seen and heard. All 3 parts are on this tape. Here in Part 1, we'll look at the preliminary concerns, materials, equipment, surface preparation, weather requirements, and application rates. In Part 2, we'll look at the chip seal procedures, binder application, chip spreading, and roller operations. Finally, in a 3rd part of the program, we'll look at some of the problems that occur during chip seal application. Now, because of our country's move to metric measurements, we're going to use metric units throughout this presentation. We'll begin here in Part 1 with preliminary concerns. The first concern is familiarity with the contract documents, your agency's bid specifications, including amendments and any special provisions. The traffic control plan is another important part of the contract documents, especially for chip seal jobs. That's because both the oil and chips can pose a real nuisance to motorists passing the work in progress. So most agencies require fresh oil and loose gravel signs on both ends of the work area. That way, motorists are warned to use caution when driving over new chip seals. On long jobs, advisory speed signs should also be placed every 2 kilometers or so. To further protect motorists and the new chip seal, pilot cars may be needed on projects constructed under traffic. So carefully review the traffic control plan. Make sure it's approved and see that it's followed throughout construction. The next step is to check the materials. The first thing you should know is that there are 3 broad categories of liquid asphalt: emulsions, asphalt cements, and asphalt cements mixed with solvents. Asphalt cements are commonly referred to as ACs, and asphalt cements mixed with solvents are called cutbacks. But all 3 are typically referred to as binder, or simply oil. Emulsions contain both liquid asphalt and water. After application, the water evaporates and leaves only the liquid asphalt on the surface. This is called breaking. You can actually see this happening, the emulsion turning from brown to black as the water evaporates. There are 2 types of emulsions, anionic and cationic, with different electrical charges. The type used has to be compatible with the chips used, and this compatibility must be verified in advance. Unlike emulsions, asphalt cements and cutbacks don't have water, so their color stays the same. We'll look again at this important difference later. Many agencies require that the binder be provided from an approved source. Some agencies may further request samples and specify the type of binder to be used. Be sure to follow your agency's requirements. Be sure the chips to be used meet your agency's specs. The size and type of aggregate depends on the number of applications to be made and the type of binder to be used. The aggregate may be gravel, crushed stone, or slag. Individual particles should be cube-shaped and as nearly of one size as possible. Graded aggregate should not be used because the smaller material would immerse completely in the binder. It's important for the aggregate to be clean. If it's coated with dust or contains clay or silt, it won't bond properly with the asphalt. Before work begins, make sure that all the chips needed for the job are stockpiled or that they're readily available. If an emulsion is specified, see that the chips are in a surface damp condition. That will keep them from absorbing water from the emulsion. Before use, they should be watered down and then allowed to drain, so that they're moist but not dripping wet when spread. Now let's go over the equipment. On chip seal projects, the first and last piece of equipment on the job is the power broom. Before chip sealing, the surface has to be cleaned to receive the oil application, so dust, sand, stones, and debris need to be swept off as thoroughly as possible. At the end of the job, the broom must sweep off any loose chips without dislodging the chips that are set in place. Damage to the fresh chip seal can result from broom bristles that are in poor condition or from too much downward pressure by the broom. So see that the bristles are long, like this. Stubby ones would more likely dislodge chips from the surface. And be sure that the broom can float. Self-adjust vertically. If it's rigid, there's sure to be too much downward pressure. Now let's consider the distributor. The distributor's function is to apply an even coverage of binder at the proper pressure and rate. Uneven coverage shows up as streaks on the surface. Too much oil in some places, not enough in others. The chips will strip from lean or thin areas, while the oil will bleed in fat or heavy areas. Bleeding creates slippery spots on the surface, a safety hazard. To get uniform coverage, first check the spray bar nozzles. They must be unclogged and uniformly angled, usually 15 to 30 degrees in relation to the spray bar. If the nozzles aren't angled properly, the spray fans will hit each other and produce an uneven coverage. It's a good idea to check the spray both before the actual application and soon after startup, so that any problems can be corrected before the operation moves too far. Spray bar height also affects proper coverage. By adjusting both the bar height and the nozzles, different spray patterns can be made as shown here. Usually a double or triple lap is used for seal coats. The distributor's application pressure is also important to proper coverage. The pressure must be correct and constant. For emulsions, a pressure that is too high, above 206 kilopascals, will cause the emulsion to break on contact with the surface. The proper rate of application is equally important, but we'll look at that later. Now, though, let's look at chip spreaders. Three basic types of spreaders place aggregate for chip seals. Two kinds of truck-mounted spreaders and a self-propelled spreader. Whichever kind is used, it must be calibrated and adjusted before the chip sealing begins. Be sure to follow the manufacturer's instructions for correct setup. As with the oil, it's important for the chips to be placed uniformly and at the proper rate. So check the gate controls and look inside the hopper. The scalping screen should be in good repair, so that no large rocks or debris will block the gates. This one obviously needs some work. If the gates and screen do not function properly, you'll end up with either too many chips or not enough. In any case, look over the spreader before the chips are applied and during the application. Stop the operation if you see anything like this. Have the equipment repaired before continuing. Now let's talk about the rollers. Their purpose is to seat the aggregate firmly in the binder. Smooth tread pneumatic tired rollers are recommended because their flexible tires work the chips into position and embed them in the oil, producing a tight-knit surface. Tire pressures for rubber-tired rollers must comply with the manufacturer's specs. Most important, tire pressure must be uniform from tire to tire. Steel-wheeled rollers may be used to roll chip seals too. However, the drums sometimes crush the aggregate and bridge over low areas of the surface, so generally they're not recommended. As for the number of rollers, 2 or more are ideal. Your agency, however, may be limited on equipment, so the actual number will vary. There's one more thing to look for on all the equipment: leaks. Spot check from time to time to see that there are no oil or fuel leaks. Both would contaminate the new surface. And that's it for the equipment. Now let's look at surface preparation. That surface may be an aggregate base, a previous surface treatment, or a plant mix course. Part of surface preparation is the initial inspection of the road to assess its condition and determine if a seal coat is the proper maintenance treatment to use. Drainage conditions should be part of this initial inspection. See that any problems are corrected before application of the chip seal. Chip seals are not recommended for treating potholes, rutting, bleeding, corrugations, or severe or extensive cracks. Even when such problems are isolated, they must be repaired before chip sealing. Otherwise, they'll just reappear on the new surface. On the other hand, chip seals are effective in treating pavements that are raveling and are oxidized and weathered. In all cases, you need to be sure that the existing surface is completely clean before the chip seal is applied. Hardened mud and other foreign matter may not be removable by brooming alone. Washing or other cleaning methods may be needed. Next, let's look at weather requirements. The temperature is always an important consideration. Most agencies require both the air and pavement temperatures to be at least 15 degrees Celsius and rising. Check your agency's specs for the exact requirements. Keep in mind that this applies to the coolest temperature on the project. If part of the roadway is shaded, check the temperature in the shade. You should also be aware that high wind can greatly affect the binder application, so don't apply the oil if the wind speed is excessive. Of course, nothing causes more problems than moisture, so the operation should not begin at all if rain is likely. Finally, you'll have to determine the application rates for the oil and chips. Many agencies use a table like this. that lists the rates for both the liquid asphalt and the aggregate. Notice that a range is given for each rate. That allows you to increase or decrease the coverage depending on the condition of the surface and on the road's average daily traffic. The general rules are, for dried out and porous surfaces, more oil should be applied. For surfaces that are smooth, non-porous, and rich in asphalt, less oil should be applied. In terms of traffic, for lower volumes, a little more oil should be applied. But for higher volumes, a little less oil should be used. As for the chips, the rate applied should leave the surface like this: one layer of chips evenly distributed, with small spaces in between. The rate is expressed as so many kilograms of chips per square meter of surface covered. To determine the application rate for the oil, you first need to know the percentage of residual asphalt content of the liquid asphalt being used. The standard for an emulsion is 63%. Dividing the chip application rate by this percentage gives you the oil application rate in liters per square meter. For further information on determining chip seal application rates, contact your state's Technology Transfer Center. In Part 2, we'll show you how to check application rates as part of the overall chip seal operation. And with that, we've looked at everything you need to do to get ready for chip sealing. Here in Part 2 of chip seal application, we'll look at checking application rates, applying binder, spreading chips, rolling, joint construction, brooming, and opening to traffic. So let's start with checking application rates. Both the oil and chip application rates should be verified. As a general guideline, you'll need between 1.5 and 2 liters of oil per square meter of surface, and between 9 and 14 kilograms of chips per square meter. To check the chip application rate, place a tarp on the surface ahead of the chip spreader, let the spreader go over it, and then weigh the chips. On the tarp, the crew then places a frame to collect the chips. The frame has an inside dimension of 1 square meter. The spreader begins applying chips and passes over the tarp and frame. Next, the crew removes all the excess aggregate outside the frame and the frame itself, leaving the collected chips on the tarp. They then fold up the tarp and weigh the chips to find the application rate. In this case, the chips weigh 10 kilograms. So the application rate is 10 kilograms per square meter. The oil application rate can be checked in the same basic way, using a pan or a piece of non-woven geotextile material, 1 square meter in size, to catch and retain the oil sprayed by the distributor, and then weighing the collected oil to calculate the rate in liters per square meter. In both cases, compare the results with the target application rates and make adjustments to the equipment as necessary. When the rates check out, you can begin chip sealing. The first step, of course, is the binder application. The binder shots must start and stop with neat, straight edges. So get the distributor in position. Then place building paper across the lane just before the start point and also just after the end point. The distributor then moves forward at the correct application speed, and the operator starts spraying on the building paper so that the application from the start point on is uniform. Be sure to end each shot on paper, too. Look closely over the binder application. It must be uniform to end up with a good chip seal. If you see anything wrong, stop the distributor immediately and correct the problem, whether it's clogged nozzles, improper pump pressure, faulty nozzle adjustment, or incorrect spray bar height. Next comes the chip application. The chip spreader should also begin and end its applications on building paper to provide a neat, clean edge to the chip seal. For starters, there should be enough trucks to supply the chip spreader steadily to avoid halting the operation. The aggregate haul distance and the productivity rate of the chip spreader are factors in determining how many trucks are needed. To control the chip application rate, the spreader operator should refer to the unit's tachometer. Also, it's a good idea to mark off the length that each truckload should cover. Whenever further verification of the application rate is desired, use the procedure shown earlier using a tarp and frame. If an emulsion is being used, be sure the spreader follows as close as possible behind the distributor, never more than 30 meters. Here's why. When placed quickly, the chips can be embedded in the oil. Then, when the oil hardens, the chips will be held firmly in place. But if the spreader lags behind and the oil breaks, a film will form. Then, when the chips are spread, they won't embed or adhere properly. The same procedure should be followed when asphalt cements or cutbacks are used, because it's almost always best to run a tight operation. That way there's less chance of traffic driving on the oil. With rare exceptions, the chip spreader should stay within 30 meters of the distributor. Regardless of the type of oil being used, the speed of the operation is important. If it moves too fast, the chips will roll when they hit the surface. The problem then is that the chip's exposed side is sticky, so they'll be picked up by the rollers and by traffic. So look over the application. There shouldn't be any oil on the top of the chips. Then it's time to look at the rolling. Rollers follow closely behind the spreader to make sure that all chips are firmly seated in the oil, and that the chips are lying flat, not one on top of another. To do that, the roller operator should establish rolling patterns by offsetting the tires and by rolling the entire surface at least twice. The rollers have to be operated slowly enough to avoid throwing the chips. 8 to 9 kilometers per hour is the recommended maximum speed. And all stops and turns should be made gradually to avoid damaging the fresh surface. Proper truck operation can help considerably in rolling the new chip seal. Like the rollers, they can stagger their paths across the road, offsetting their wheels so that each truck rolls a different part of the surface. Beyond that, trucks have to be careful not to damage the chip seal. So the slower the speed, the better. And each turn and stop should be as gradual as possible. Remember, any sudden movement on a new chip seal will dislodge the chips. In addition, all operators should avoid driving over any exposed oil. And that brings us to joint construction. There are two types: longitudinal, which run along the length of the road, and transverse, which run across the road. First, longitudinal joints. When the adjoining lane will be chip sealed, there should be a narrow strip of oil that the spreader doesn't cover. Some refer to this narrow strip as the meat line. Whatever it's called, it should be left uncovered because there's not enough oil there to hold the chips in place. This is because there's no overlap at the end of the distributor spray bar. The chip spreader operator has to be careful, though, to make the meat line only as wide as the spray from the last nozzle, about 20 centimeters. On the next pass, the distributor has to line up so the last nozzle sprays the meat line. This double spraying of the meat line gives the surface the necessary coverage and ties the two applications together. Be sure, however, that the meat line is never made in wheel paths. Meat lines can be constructed only at the center line of the road, the center line of a driving lane, or at the edge of a driving lane. And no meat line should be left open overnight because exposed oil is very slippery. This means that the ends of adjacent applications should be together when work stops for the day. As for transverse joints, every application that takes off from a previous one has to begin on building paper. The reason is simple but important. You have to avoid spraying oil on the chips already in place. If you don't start the application on building paper, you'll be placing one application over another and building a bump in the surface. As stated earlier, use building paper at the end of each application too. That's the best way to keep the edges neat and even. Be sure to dispose of this paper properly, according to the regulations in force. Now let's look at brooming. While some amount of loose chips is unavoidable, they need to be removed by light brooming to prevent broken windshields, and also to keep them from dislodging the bonded chips. But be sure the brooming itself doesn't dislodge the aggregate. If it does, suspend it until a good bond has formed between the binder and chips. Also, make sure the broom is not applying excessive pressure to the surface. In rural areas, the loose aggregate may be broomed to the shoulders of the road. In urban areas, however, they should be broomed to the curb or center line and then removed manually or by vacuum device. And that brings us to the final step of the operation, opening the chip seal to traffic. Opening fresh chip seals to traffic is desirable. The traffic will help to roll the surface further. Still, there are a couple of things to keep in mind. First, you want the traffic to travel slowly, no more than 40 kilometers per hour. And second, you don't want sudden accelerations or slowdowns. They would likely dislodge the aggregate. Pilot cars and flaggers are recommended to direct and control the traffic flow. In the absence of a pilot car, reduced speed limit signs should be posted. And that brings us to the end of this second part of the video program. As you've seen, each and every step is crucial to the success of the application. Your thorough attention to the details will result in a good chip seal every time. In Part 3, you'll see typical problems that occur in chip seal operations. This third and final video segment of chip seal application shows some of the problems and pitfalls that may occur during the operation. It's based on a presentation developed by the Oklahoma Department of Transportation. Improper equipment maintenance or operation causes most chip sealing problems. A major failure in any key piece of equipment will usually halt the entire process. The most serious problems are likely to occur at the asphalt storage facility. Overheated flues, a half-filled booster pump, or return lines containing oil pockets can cause explosions, resulting in severe damage and injury. Premature opening of the valve during distributor loading can produce an unexpected surge of hot oil, creating a big mess and maybe severe burns. A full distributor tank does not eliminate all danger when firing the burners. Faulty plumbing is likely to give the operator a surprise. Telltale vapors, drips, and frost buildups all indicate leaks in the propane burner systems. A poorly maintained spray bar with a heavy buildup of cured binder usually leads to partially clogged nozzles and, consequently, an irregular fan pattern. Improper nozzle settings may compound the problem and result in a seriously uneven binder application. If a distributor in this condition is used on the job, several problems will occur with the binder. First, when a clogged spray bar applies binder under normal pressure, the oil flow will be insufficient and the fan profile will be poor. If, on the other hand, the pressure is increased beyond the recommended 206 kilopascals to compensate for the restricted flow, the high pressure can cause emulsion oil to break upon impact with the road surface, separating the water from the asphalt and ruining the qualities of the binder. The higher pressure also makes the oil spatter excessively, propelling droplets over the entire width of the adjacent lane. Where tires of oncoming traffic will pick it up. But the most serious consequence of this problem is when the oil spatters onto a freshly chipped lane where it lies free to be picked up and tracked by tires. Another cause of surface oil is grass and debris that stick to binder-coated distributor parts and then drop into the spray path to be covered by oil. This debris often protrudes through the surface after the chip application. The worst spray bar problem is revealed by this trail of binder. A serious leak in the distributor's plumbing with the bar under pressure leaves a thick pool of oil on the pavement. When the binder is applied, this concentration of oil will not be apparent. But when the chipper covers the pool with aggregate, the problem rises to the surface as the first wheel passes over it. The chips are pressed down and the oil seeps through. Subsequent tires and rolling equipment pick it up and track it. A problem not related to equipment maintenance arises when the wind distorts the spray fans. Gusts of wind, in extreme cases, can totally interrupt the uniformity of the binder coat. So be careful in windy weather. And watch out for drafts caused by big trucks. This line of puddles left by a leaking spray bar is typical of the many distributor-related problems that can profoundly affect job quality. Since most serious problems of chip sealing involve the binder oil in some way, it stands to reason that a well-maintained and operated distributor can keep these problems to a minimum. The chip spreader, like all the other equipment, should be checked each morning for operational readiness and safety. But even then, problems can still occur. If one of the gates jams in a closed position, it shuts off a small portion of the chip fall, as is clearly shown by the opening in the chip fall and a corresponding strip of exposed binder on the surface. If a vehicle tire gets into the oil, the problem is seriously compounded. A gate can also jam in an open position, spilling excess chips onto the roadway. While this problem does not threaten the job quality, it must be corrected before the operation continues. Another chipping problem occurs when the dump truck bed is raised to transfer aggregate into the chipper's hopper. If the volume control guards are worn or missing, the aggregate will spill over the sides and accumulate in little piles on the surface. This same overflow can happen when the chipper is in motion, although here the spill is less apparent since the chips are dispersed along the roadway. The aggregate lost over a period of time can be considerable. Also, these little chip piles can cause trouble for the trucks and rollers. Big spills, on the other hand, can happen if the chipper and dump truck disengage during spreading. While this machine's hitch is designed to prevent disengagement, many chippers have a simple hook that doesn't completely surround the steel rod connection of the truck. Should the chipper operator fail to verify the connection, the entire load could be dumped when the chipper pulls away. Disengagement can also occur when the machines are in motion, by raising the truck bed too high or running over chip piles. In either case, if the rear of the truck is lifted high enough to clear the chipper hitch, the load ends up on the roadway. The chip fall should be continuously monitored, not only for excessive chips, but for thin spots. If the road coverage is poor, it's likely that the spreader box or screens have become clogged with sand or debris. Here's a safety point. Operators of heavy equipment aren't normally required to wear a safety vest because the equipment is more visible to drivers than is the vest. But it's hazardous for the operator to dismount his machinery and set foot on the roadway. Improper equipment operation is responsible for many problems, nearly all related to the fresh binder. A careless broom operator may do more harm than good when trying to clean the road shoulder too near to the distributor, especially if the wind is blowing in the wrong direction. The broom operator may also contaminate the fresh chips by rolling his tires in the oil and getting the broom too deep into the binder strip. This throws oil-covered rocks back onto the chipped surface to be picked up and thrown by vehicle tires. Every effort should be made to avoid contact with the exposed binder strip, especially when driving onto the freshly chipped surface. The consequences will speak for themselves. Finally, tire contact with the freshly chipped surface must always be handled with care. Any twisting, spinning, or sliding of the tires will roll the chips over and expose the oil. Often, both the rock and the oil are removed, requiring difficult manual repairs. Once you've developed an eye for problems that can happen during chip seal application, the clues are generally easy to spot. Sometimes we may be our own worst enemy because the first wheels to touch the freshly chipped surface are those of our own equipment. The key to a successful chip seal job lies in proper procedure, crew awareness, and attention to detail. For more information and help with your chip seal operations, contact your state's Technology Transfer Center.